This video is over the Chapter 5 AP exam multiple choice questions, which remember will show up on the test. So it's a good idea for you to study these. So the first set of questions actually refer to this equation. We have ourselves potassium plus chlorine, both elemental. They react directly to form KCl, which is a salt, and the accompanying heat change of the reaction is given. Refer to the information in the table to answer the questions. Now what they've done here is they've broken up the reaction, which is already simple enough, it seems like, just a combination of two elements, into miniature reactions, for example, the first reaction here shows potassium going from a solid to a gas. In order for it to react, it has to get heated up to a gas. Then it shows potassium being an electron being removed from potassium. Then chlorine is shown being broken up. Then chlorine is shown being added an electron. And finally, the ions which formed are shown being put together into the final salt. So you can combine these reactions together to come up with this final equation. And remember, for this, we use Hess's law. So let's see if we can use this. It's a bit strange, but see if we can use this to answer the questions. The first question says, number 13, how much heat is released or absorbed when 0.050 moles of Cl2 gas is formed? So this is a quick stoichiometry question, and because we have ourselves 0.050 moles of Cl2, it looks like 1/2 of Cl2 forms this much heat. So for stoichiometry, remember, we simply want to convert from moles of, in this case, Cl2 into heat. Now the relationship is 1/2 mole of CO2, so 1/2 mole gives you negative 437 kilojoules. And the idea is what you're doing is you're dividing 0.050 by 1/2. Now anytime you divide by 1/2, it's the same thing as multiplying by 2 or multiplying by the reciprocal. I'm going to show you these questions without using a calculator, or try not to use a calculator, because that is how the AP exam multiple choice questions work. So effectively what you're doing is you got yourself 0.1 moles. So since you have yourself 0.10 moles, which is 1/10 of a mole, then 1/10 times 437 gives you, you essentially just move the decimal place left once, and you get yourself negative 43.7 kilojoules. So since we have 1/10 of a mole, we've got ourselves negative 43.7. Here it says released or absorbed, and because we're forming KCl as the reaction is written, we are releasing energy. So it should be released. B should be the correct answer. 43.7 kilojoules are released. Take a look at the second question. The second question is a bit different. Here it says, what remains in the reaction vessel after equal masses of potassium and chlorine have reacted until either one or both of the reactants have been completely consumed? This is another stoichiometry problem, but this is a limited reactants stoichiometry problem. This is not necessarily referring to Chapter 5, but just using equations. So we have equal masses of potassium and chlorine, and it doesn't matter what masses you use as long as they're equal. I propose using the mass of potassium from the periodic table. So because the molar mass of potassium is 39, roughly 39 grams per mole, why don't we use 39 grams of each? So we'll say we begin with 39 grams of potassium, we begin with 39 grams of chlorine. Now, if we begin with 39 grams of potassium, the reason I chose that is because you get yourself 1 mole of potassium. Because if you convert from grams to moles, you get 1 mole of potassium. So we'll get 1 mole of K, and then we'll get, in that case, let's see, we'll have to convert from 39 grams to chlorine. Now chlorine, the mass of chlorine is 3545 on the periodic table. So since you have Cl2, you have to double that, which gives you 70.9, or roughly 71 grams per mole. So what you're effectively doing to get how many moles you have of chlorine is you'll have to do 39 grams divided by roughly 71 grams in a mole. So this is for chlorine, Cl2. And again, let's try to think about this without the use of a calculator. This is a little difficult to divide these two numbers. But think of it, if I had 40 grams here, and if I had 80 grams here, I would have 40 divided by 80, which gives me 0.5, correct? In this case, I have about 40, but I have less than 80, which means my answer is going to be a little higher because I'm not dividing by as big a number. So I'll actually end up, we'll say with 0.6, roughly 0.6 or so moles of Cl2. So this is, you could have done this with a calculator. I'll let you use a calculator on my tests. So you could have simply chosen any grams. You could have used 100 grams for each and then converted. And then what you would see is that since I have 1 mole of potassium and about 0.6 moles of my chlorine, the reaction needs 1 mole of potassium for half a mole of chlorine. So this whole 1 mole will be used up, and half of this will be used up. So, or not half, but 0.5 moles will be used up, leaving 0.1 moles left. And so, in other words, after the whole 1 mole of potassium reacts, you will have 0.1 moles of chlorine left. And that essentially is the idea. So you'll have a little bit of chlorine left, 0.1 mole, 1/10 of a mole, and then obviously you formed a bunch of KCl, so that's what you'll have in the reactant vessel. So really we'll have KCl, this is part C right here. We'll have KCl and Cl2 only. All the potassium should be used up. So hopefully that one is a little more involved, it made sense. Let's take a look at the next one. The next one says, which of the values of delta H for a process in the table are less than 0, i.e. indicates an exothermic process. So if you take a look at these reactions in the table, we're asking for which one is exothermic. Now remember, anytime we break bonds, we have to put energy in. So endothermic processes are always breaking bonds, and if we make a bond, energy is released. In the first case here, is this exothermic or endothermic? Are we making a bond or are we breaking bonds? Well, we're going from a solid to a gas. That requires the breaking of bonds because solid particles have attractions, have bonds between them. So this one would be endothermic. And remember, endothermic is represented with a plus. The second one, we're doing a similar thing here. We're removing an electron from potassium. So you're breaking off an electron. Again, it's endo because you're breaking a bond. So this will also be positive. In the case of chlorine here, we are taking a chlorine molecule and breaking it in two. So you actually are taking a chlorine and breaking this bond essentially. So this is also endo. Again, we are breaking bonds. Since it's endo, the delta H for the process is positive. In the case of this happening, we are making a bond. We are giving an electron to chlorine, which means chlorine accepts the electron and makes a new bond. This one's actually going to be exothermic, represented by a negative because heat is released. And then likewise here, we're putting potassium plus and chlorine plus together into a compound. And this is definitely exothermic. We are forming a bond as well. So it is actually these last two equations. So Y and Z are the ones that are exothermic. So we can actually choose those as needed. So Y and Z only, the answer then here would be B. Okay, let's answer the last one here, which is down below, number 16. And here it says, which of the following expressions is equivalent to delta H for the reaction represented above? So we're looking at this reaction here. And essentially they've combined a few reactions together to give us this final reaction. Let's see which they have combined. And we'll probably use Hess's law for this. So if you scroll up, take a look at some of these in the table. It looks like we have we have a Cl2 on the left side. That must have come from this reaction. So we have Cl2 on the left side. Looks like we have two Cl minuses on the right side. The Cl minus came from this reaction. We have 2 of them, so we'll actually have to double this reaction, multiply it by 2, which means we will double the y. And then if we do that, everything else should cancel out. In fact, let's go ahead and try that here. I'm going to put 2's in front of everything. So here comes a 2, and here comes a 2. So looking at the reaction, we have 2Cl, which cancel out. Notice these 2Cl's are the same thing, so they cancel out. And what we're left with, essentially, are Cl2 on the left side. That's exactly what we want. 2 electrons on the left side. That's exactly what we want. And we have 2 Cl minuses on the right side of the arrow. That's exactly what we want. So effectively, what we're doing is we're adding x plus 2y. And it's a Hess's law, given from a different angle. And they often like to do this with AP exams. So x plus 2y, is there a choice for that? There is. Or we are happy to choose it. So this then would be the answer. Okay, we'll do the next 3 questions in the following video. Hopefully you enjoyed this one.